Modern enterprise AI deployment begins with a familiar checklist. Organizations demand strict security, privacy protections, and high accuracy from their models. They rely on standard risk management protocols to keep the system from fracturing. These trust-by-design frameworks are treated as comprehensive solutions. In practice, they form an operational shell. They ensure local components function correctly, but they leave the enterprise structurally incomplete. A technically competent AI agent can easily pass all local compliance checks, yet that same agent can remain embedded in a fragmented institutional environment, systematically exporting errors, delays, and instability to other departments. The Bridge360 Metatheory Model identifies this failure state as a Potemkin attractor. The visible signs of corporate governance are present: committees, checklists, and compliance labels, but they mask structural non-governance beneath the surface. The core misconception in the modern enterprise stack is the assumption that governing individual AI agents naturally produces a governed enterprise. It does not. Scaling AI safely requires moving past individual checkbox compliance. Organizations must map and govern the unmanaged throughput and architectural leakage occurring in the spaces between their systems. Industry standards frequently treat AI trust as a psychological condition, a feeling of confidence that a system was responsibly designed. The Bridge360 framework rejects this definition. Intelligence in this model is not a simple truth-seeking mechanism. Drawing on the foundations of information theory, intelligence is redefined as a process of entropy management, maintaining stability and navigability under pressure. To prevent unmanaged disorder from spreading through an organization, every point of human-AI dependence must be formally authorized. This turns trust into a revocable governance license, the specific mechanism that permits an agent to carry the burden of a corporate process. This license carries strict prerequisites. To maintain authorization, the operational dependence must remain fully inspectable, rigorously stress-tested, and bound by a strict entropy budget that limits the disorder the agent can create. If an AI system acts sequentially, and those actions cannot be deterministically reversed, the permissible trust allocation must immediately contract. Trust is never a permanent label applied after a successful pilot program. It is a conditional, operational state. It expands, contracts, or is suspended based on continuous evidence. This axis maps the unified probability space. It ranges from 0, representing perfect, rigid order, to 1, representing maximum disorder. Together, this forms the spine corridor, the declared bounded operational environment for any enterprise AI agent. To track an agent's stability along this space, Bridge360 uses the Normalized Entropy Eigenvector, or NEE. As the agent processes data and makes decisions, this metric shifts to reflect its current entropic load. The system designates the interval between 0.45 and 0.65 as the epsilon spine. This is the only navigable zone where a system balances sufficient structure for governance with enough adaptability to function. Dropping below 0.45 enters the inbreeding zone, where the agent becomes brittle and fragile to new perturbations. Spiking above 0.65 enters the blowout zone, dominated by chaos and hallucinations. Crossing these boundaries triggers a selective friction tripwire. The system responds with an immediate intervention, reducing the agent's amplitude and restoring a known, safe-state snapshot. Organizations can authorize bounded acceleration, but that authorization holds only while the agent remains measurable and navigable strictly within this epsilon spine. Conventional enterprise AI governance typically measures response times, accuracy, and user satisfaction. Bridge360 introduces rigorous entropy accounting to track what these metrics miss. The first measure is operational leakage. This captures deviations, errors, and inefficiencies occurring directly within the AI agent's intended workflow. The second, and more critical, is architectural leakage. This accounts for the burden, risk, and instability that the AI exports beyond its immediate workflow into other parts of the enterprise. Consider an AI procurement agent that saves its home department 1,000 employee hours. If downstream teams must spend 500 hours verifying its outputs, remediating errors, or managing newly accumulated technical debt, that cost must be tracked. Standard return on investment accounting will classify the 1,000 saved hours as a massive success. It ignores the 500 hours of systemic degradation transferred elsewhere. A dedicated leakage ledger corrects this. Without it, organizations mistake the externalization of entropy, dumping workload onto customers or other departments for genuine operational efficiency. Tech leaders frequently call for observability everywhere and assign identities to their AI agents so they can be governed like human users. In practice, enterprise transparency often degrades into generic disclaimers stating that AI-generated content may contain errors. This provides no actionable governance. This diagram outlines the Bridge360 solution, caveat vectors. These are structured, machine-readable, decision-relevant qualifications explicitly attached to every significant AI output. These vectors enforce hard limits. A knowledge limitation tag might specify that vendor ownership data is incomplete, actively blocking the recommendation from triggering an automated payment. Knowing which bot performed an action provides basic agent identity. Bridge360 expands this into a path and provenance signature. The signature answers specific questions. Under whose authorization did this agent act? Inside which corridor? And using what precise data lineage, prompts, and transformations? This level of systems thinking stems from 35 years of academic development and rigorous modeling at the University of the Philippines. It anchors enterprise policy in robust mathematical theory. Granting an agent an identity without tracing its inferential lineage leaves an enterprise blind. It allows recursive errors to spread and enables authority laundering across business units. The mechanism that governs state transitions in the Bridge360 architecture is the handshake protocol. A handshake is required whenever an agent crosses business units, shifts from a pilot environment to full production, or executes a new model update. The protocol relies on strict band classification discipline. It separates exploratory commentary in Band C from conditional evidence in Band B and certified action guidance in Band A. This discipline prevents authority inflation. A persuasive demonstration generated in Band C cannot silently migrate into an action-authorized Band A status without passing the gate. Passing requires rigorous evidence. The system must satisfy domain-specific observables, survive explicit perturbation tests, and secure dual-key authorization, requiring both machine-level corridor compliance and meaningful human approval. The handshake protocol transforms responsible AI principles into a sequence of explicit, inspectable, and reversible governance transactions. Standard frameworks ask how enterprises can deploy AI rapidly while retaining general confidence. Bridge360 asks a more demanding question. Under exactly what bounded, evidenced, and reversible conditions may an enterprise continue to authorize dependence? Observing a system go off the rails is insufficient. Stopping an agent requires deterministic rollback semantics, mapped and defined long before a breach ever occurs. This rigorous governance is not a wall designed to stop innovation. It is the essential infrastructure required to accelerate safely. Shifting from local checkbox compliance to a true entropy-bounded architecture ensures enterprise AI dependence scales safely. It is a decisive upgrade to the modern technology stack.